decided to join this Demo Day program, which will last from which will start right after the summit and then conclude at the finale. So during this typically 6 to 8 month period, the students would go through a series of training with a lot of help from our faculty, staff, and our community at large. And so today we have 7 teams of students participating in this program in basically the past year. And of course, during this year of training in the demo day, they've learned a lot, right? So they have interacted with the industry, the government, and of course the academia to get their feedbacks and refine their research and also finalize their presentation. And so now they have a chance to present their work in front of a panel of judges. And so these 7 teams, some of them choose to present their work as a candidate for commercialization, and some of them choose to present their work as essentially a research technology that they will continue to develop. So, like I said before, we really get a lot of help from basically everybody at Georgia Tech and also beyond. I mean, you can ask the students who actually participated, who have participated in this program. They can tell you that there's a lot of work, but they also learn a lot. And the reason that they learn a lot is not just the training programs that we put together, but also, like I said, again, we get a lot of help from beyond our faculty group. So in particular, I would like to thank the panel of judges today. So we have John Shantz, he's a TDF partner, and Jerry Palullo. A lot of you probably have heard his lecture. He's CISO of IISP Intercontinental Exchange. And also we have Blake Patton. He's a managing director of the ATDC Venture Fund, and also he started the Engage program, which gets Georgia Tech involved in a lot of venture and investment opportunities. And also Rahul Saxena, he's those of you who are at Georgia Tech, in particular those who have participated in the CareerX, you know him well. He's essentially running the CareerX program at Georgia Tech. And also we have Melissa Hafner. She's with the Venture Lab, and she's been helping us to design our curriculum for the Demo Day program. And within Georgia Tech, the sort of the IISP, we have Gloria Greisman. She's been running this program for several years now, and I think a lot of students, whether you're participating or not, you should know her very well. She really provided a lot of the logistics and also guided many teams through the program. We also have Carly Weston and Tim Hines. They had helped us on the communication side, not just on the publishing materials, but also some of the audio videos and also our websites. And like I said, we have 7 teams that they're going to present. And also we have, I will also just take a side note to say that for those of you who are new to this program, or this is the first time you participated in the Demo Day Finale as part of the audience, I encourage you to talk to these students who are one of those 7 teams. You could ask their experience, learn from them, and I would really encourage you to participate in the Demo Day for the coming year. We also want to thank the Tech Square ATL Social Club. I think this used to be the garage for helping to produce and live stream this event today. Now, next I want to extend a special thanks and a special welcome to Rahim Beya. He's a security veteran. I mean, those of you at Georgia Tech should know. One of his students actually won the finale last year. is doing a startup now. And on that note, I also want to say that our first winner, right? So this is the 5th year. So 5 years ago, with the first winner, Monsieur Ahmad. His technology led to the startup called Flowscope. I think they just closed the Series A. So that's a success story right there. So Rahim is now the Vice President for Interdisciplinary Research at Georgia Tech, also Professor of ECE, and he's also involved in a couple of startups. So he's going to take us through this event. So Rahim, you want to take over?
All right, thank you very much, Winky, for the warm introduction. I'm very excited to be here. I want to take a moment to acknowledge the great work that's done by the IISP and the impact that this program can have on the students that actually go through it. As a faculty member and an entrepreneur and an academic leader, firmly believe that every student should be exposed to real world problems and how their research is relevant, and really focus on impact outside of the academy. It's great to write papers, but we really want to see if we can influence the real world sooner than later. And as you mentioned, Winky, one of my students, Tawheed Shikari, was a winner last year, and he really credits his program for helping him understand the commercialization process and how to realize the impact of his research. And one thing that was really nice is, he started this project, and it really served as a seed for one of our larger, it's about a $1.2 million NSF grant, really based on that idea. So we get a chance to, it was really advanced. We get a chance to sort of incubate it a bit more, mature it a bit more, and then hopefully eventually roll it out. So here is the agenda. Well, one thing I just missed. So the agenda is going to pop up shortly, and I want to take a minute to I'll outline the program and how you can participate. We expect you to participate. Oh, there it is. Specifically for the People's Choice Award, right? So that's coming. So you got to pay attention. You got to listen, and you got to be excited and vote. And we only do legal voting. We're going to vote once for the People's Choice Award. So you see the agenda now. We're going to begin by introducing the judges and the students participating in the commercialization track. And then one by one, the students will present their research and actually answer really tough questions from this esteemed panel of judges that we have. We'll open it up to the audience to vote for this People's Choice Award for the commercialization track. And we'll let you know, I mean, stay tuned, but we will certainly alert you when it's time to vote. Next, we're going to introduce the research team. And they will briefly describe teams, and they'll briefly describe their research. And I'll tell you a little bit more about the difference a little later. These students present their research to the judges last week, and they'll also get feedback today. And next, we're going to close the voting for the People's Choice Award and begin presenting the awards. Once we close the voting for that award, the winner will be announced. Then the judges will announce the winner for the commercialization track, and then the winner for the research track. And then finally, we're going to have a special announcement by Rahul Saxena regarding the winner of the CreateX Launch Award. So that'll be announced. So now let me introduce, or actually I'll ask the esteemed judges, the panel, to give a quick introduction, starting with Blake.
Thanks, Raheem. I'm Blake Patton, the managing partner and founder of Tech Square Ventures. We're an early stage venture firm based here in Atlanta. Since our founding, we've invested in over 50 early stage technology companies, and we're also the venture firm partner with Georgia Tech and Engage, a corporate innovation and venturing platform. And excited to be here. Thank you.
Hi, everyone. Jerry Perullo here. I'm with ICE, as Wenky mentioned, or Intercontinental Exchange. We're a local firm Known for running exchanges and clearinghouses around the world, though. The biggest name brand that we have is the New York Stock Exchange that we purchased about 7 years ago. I run information security as the Chief Information Security Officer, and I've spent a lot of time over the years with IISP, GCISC before that, and recruiting heavily from Georgia Tech and working with students on projects, bringing someone over as an intern, and even spending a lot of time even lecturing in some of the classes. So I'm really looking forward to working with all of the participants today.
Hi, everyone. My name is John Shantz, and I'm a TDF venture partner and have been a venture partner for the last 3 years. We're a $150 million venture fund that focuses on Series A investments where cybersecurity is a big part of that. Prior to becoming a venture partner in 2017, I spent 30 years as a global hyperscale tech exec. Most recently, I spent over a decade as the Chief Network Officer at Comcast. I worked at America Online globally and Sprint. And during those 30 years, or 25 of those years, cybersecurity, from strategy to talent to culture to the CISO reporting within my organization, cyber ops and boards, is a lot of the experience that I bring. I have experience protecting consumers, protecting enterprises, employees, and information, as well as some of our core national infrastructure with the public internet. So it's great to be here. It's great to be a part of Georgia Tech's Institute for Information Security and Privacy, and I'm looking forward to today and the great presentations from our students.
Okay, let's see. It should be switching back to me. I'll just start talking, even while you're here. All right. So truly impressive group of judges, and thank you so much for taking the time to be here with us. We know you can, but we appreciate it. So let's talk a little bit about the commercialization track. So this track includes an extensive program where our students can learn various entrepreneurial methods. And this year, many of the participants actually had an opportunity to go visit RSA, which is one of the largest cybersecurity conferences in the field, or they also had an opportunity to choose another conference. And the goal was to go and conduct customer discovery, right? So let's go and talk to people and find out where the gaps are and where the problems are. So let me go ahead and introduce, some of the stars of the show, our students. I'll ask each of the PhD students to introduce yourself, and let's start with Ranjita.
Hi, my name is Ranjita, and I'm a third-year PhD student advised by Dr. Brendan Saltafamaggio at the Sci-Fi Lab, the Cyber Forensics and Innovation Lab. We call it the Sci-Fi Lab. My work majorly focuses on malware behavior modeling and web attack forensics. Today, I'm presenting my research called TARDIS, Rolling Back the Clock on CMS Targeting Cyber Attacks. I hope you enjoy my presentation.
Okay, Chin Chong is probably looking for a mute.
Hello, everyone. My name is Chen Xiongqian. I'm a 6 years PhD student working with Winky. My research interests are software security and system security. Recent years, I have been focusing on reducing software's attack surface by removing unnecessary features. Today, I will present one of the works, Razor. Thank you.
Hi everyone, this is Erkan Uzun. I'm a 6th-year PhD student advised by Wenki Lee. I'm mostly working on privacy protection of biometric authentication and recognition systems. Today, I'll introduce our new technology for privacy-preserving surveillance. I hope you enjoy the show. Thank you.
This is hello everyone, this is Paritosh. I'm a fifth year PhD student at Georgia Tech at the School of Industrial and Systems Engineering. I'm being co-advised by Professor Nagi Gabriel and Professor Edmund Chow. My research is mostly on decentralized optimization and decentralized industrial analytics. And lately we've been looking at how we can use decentralization to ensure privacy and security in the industrial IoT and analytics space. And we present to you Blockalytics. That has been our the result from our research so far. And I'm looking forward to engaging with all of you. And please reach out to us with comments, suggestions. And I'm looking forward to meeting all of you. Thank you.
All right, thanks. I think you will appreciate that this truly is an outstanding group of PhD students. So now we're going to move through the presentations. And again, as a reminder, they'll be followed by questions from the judges. And we're just going to go, one after each other till we finish. So this is an opportunity to make sure that you are paying attention and that you are looking at how the students answer questions because you're going to ultimately vote for the People's Choice Award based on the presentations and questions.
Good morning. My name is Ranjita, and I'm presenting my research on TARDIS, rolling back the clock on CMS targeting cyber attacks. Hosting websites have become very easy. So easy that my grandma in India has a website too. All of this has been made possible by the rise of content management systems. Such as WordPress, Drupal, Joomla, to name a few. And they majorly marketed to non-technical users. CMS-based websites can be thought of Good morning. My name is Ranjita, and I'm presenting my research on TARDIS, rolling back the clock on CMS targeting cyber attacks. Hosting websites have become very easy. So easy that my grandma in India has a website too. All of this has been made possible by the rise of content management systems such as WordPress, Drupal, Joomla, to name a few. And they majorly marketed to non-technical users. CMS-based websites can be thought of as an amalgam of layered interpreters and softwares, and the CMS itself is made up of CMS core and CMS plugins, which contains code templates, making it easy for someone such as my grandma to drag and drop and build a full-fledged website. Over 55% of the world's websites run on content management systems. Turns out, attackers love CMSs too. Their huge market share, combined with the less technical users, make them a ripe target for attackers. My research found that CMSs are infected with long-lived multi-stage web attacks. In collaboration with CodeGuard, one of the largest website backup service providers on the market today, I studied over 300,000 websites, spanning about 1900 days going all the way back to March 2014. And I found that 20,591 of these websites were compromised with long-lived web attacks. Now let's consider a situation where my grandma's website is infected. She knows that the research solutions are too tedious to apply. The industry standard is not working. The industry standard of using a backup service provider with an antivirus or AV on the backup side. This is not working because AVs either generally have too many false positives or they cannot catch 0 days. So we're only left with the backups in hand. How do we help my grandma recover from these attacks? That's when TARDIS comes to the rescue. Using the concept of time travel, TARDIS takes all of the website backups as input, goes all the way back in time, analyzes every single snapshot, records a bunch of behavioral metrics for every single snapshot, correlates these metrics to extract what we call the compromise window, or the period of time during which the nightly backup snapshots cannot be trusted. I deployed TARDIS in the wild on these 300,000 websites. And as mentioned earlier, TARDIS found 20,591 attack victims. In comparison, the AV on the backup side found only 91 websites as compromised, which is less than 1% of what TARDIS found. Furthermore, of these 91 websites, only 29 websites were rolled back in an attempt to clean up. What makes it worse is 19 of the 29 websites that did a rollback found reinfections, showing that the industry standard is clearly not working. With some help from Georgia Tech's Venture Lab, I started the lean startup process to figure out if TARDIS has a market. I started the customer discovery process and interviewed 59 people across 4 trade shows, 3 WordCamps and 1 DrupalCamp. The attendees at these trade shows are mostly hosting providers, small business owners, bloggers, who come from all over the world. I ended up interviewing people from US, India, Japan, Iran, and Korea. Before starting the customer discovery, my assumption was that all users are extremely concerned about the security of the web server. I found that bloggers are constantly faced with web attacks, but they're not as concerned because the consequences are insignificant. They don't hold as much sensitive information on their web server. In contrast, small to medium-sized businesses with about 100 clients or so are also faced with web attacks, but they care deeply about securing their websites. That's majorly to protect themselves as well as their clients from a potential security breach. I found that because TARDIS has high impact, international significance, and commercial value, I built a hypothesis based on these interviews. My hypothesis is that TARDIS as a service could provide value to both hosting providers as well as website operators. It reduces the friction associated with existing research solutions. It's an easy click and done solution. It enables rapid recovery from web attacks, and it uses the already existing infrastructure of the nightly backups. In conclusion, TARDIS is a novel technique that finds out compromises in website backups and has uncovered more than 20,000 attack victims.
Thank you for making it to the end. Feel free to reach out with questions.
I guess as your go-to-market for this, if you were to take this and commercialize it, what do you have to do to make it work across these different content management systems? Is it custom to, does it have to be developed for each content management system, or how do you integrate with that?
It doesn't have to be developed for each content management system. So it is CMS agnostic at this point. It only relies, so it looks for behaviors, malicious behaviors, which doesn't really care about the underlying CMS framework. So it sort of untangles the CMS application logic from the malware logic. And it looks for behaviors. So scaling it to different CMSs is not a problem. In terms of taking it to the market, I guess what needs to be done right now, considering we have a fully working prototype that has been tested on over 300,000 websites, what needs to be done right now is one, build a UI, and two, find the first customer to get it to, first customer who's willing to deploy it. But one more thing that's missing right now is a UI that makes it attractive.
I find it very, very interesting and good that you're focusing on the backups of the websites and doing that. My question is, why not go with that approach and just go ahead and run analysis against the last known backup, against all the known vulnerabilities and exposures of what's there, so that could be highlighted for remediation very quickly?
My follow-up work did find that attackers are selling against, there is a lot of supply chain attack happening here, and it's more than $200 billion market right now, where they buy popular plugins and inject malicious code in there. So when people to update their web server, the malicious code gets on there. And then they use it, they monetize it based on malvertising or black hat SEO campaigns. So I do have a small prototype working, but because research was not published, I did not integrate it into TARDIS. But when I take it to market, it's going to be integrated within the provided solution.
Hello everyone. Today, I will present our project Reader. It's designed for removing unneeded code in software. Imagine that when we install Adobe PDF Reader, we just want to use it to read and edit PDF files. However, besides providing functionality for editing and reading, the Adobe PDF Reader has other functionalities. It has a complete mail server, and it even has audio and video playing modules. In software, for the needed functionalities, the related code is well investigated because it's always used by users in their daily lives. But for unneeded functionalities, the code is rarely used, it's unknown and dangerous. We call this unneeded and unknown code bloated code. Bloated code have caused lots of real-world problems. A notorious example is Heartbeat bug. It happened in 2014. At that time, it took over more than 60% of websites. Even Google and Amazon were affected. With the bug, the attacker can steal servers' private keys, and they can steal any data from any users. After realizing the problem, the software community have proposed software debloating to remove unneeded code. But the existing systems have limitations. First, they require source code, but sometimes source code is not accessible to users. Second, the code removing is at module level. In a security conference, the security manager from local TV, he told me, they customize the Linux kernel to remove unneeded modules, but it's not enough. Because in most of the cases, even a very little piece of code is needed. They have to keep the whole modules. Third, removing code from software affects the original functionalities. For example, After removing pre-installed apps on Android phones, the phone cannot boot successfully. To address these problems, we proposed Razor. It's a smart and fine-grained framework for removing bloated code in binaries. Here is how it works. First, when users are using software, Razor collects the using history with very low overhead. Then, with the using history, Razor uses heuristic to learn and to identify needed and unneeded features in software. In the end, Razor directly rewrites software to remove code for unneeded features. We have tested Razor on Firefox and Foxy Reader, which is a commercial software for PDF reading. We can see, with applying heuristic CLib, we can remove around 60% of the code for Firefox and remove around 87% code for Foxy Reader. And for both software, after removing unneeded code, they can run normally without causing any crashes. I'm glad to introduce our team. Mansell and I are PhD students in Georgia Tech. Simon is a research scientist in Georgia Tech. Hong is now a professor in PSU, and Professor Tae-Soo Kim and Professor Winky Lee are also from Georgia Tech. I'm happy to take questions from here.
Yeah, this seems like a really unique way of looking at it, especially kind of runtime versus trying to do things with source code and that sort of thing. What are the top examples of attacks in the wild that you came up with that leveraged this, or even the classes of them? You mentioned Adobe, that kind of thing. Are there some major areas, or are things like Microsoft Office files and macro attacks and that kind of thing in scope as well for this project?
I think there's no specific attack. There's no specific group of attacks targeting on this rarely used code. But in wild, actually, we found that for browser, we found that more than half of the attacks can happen on those codes that are not used on daily websites, like very popular top 1,000 Alexa websites. So we think that the attacks are there, but we don't have a specific definition of those kind of attacks.
Yes, yeah. Just a quick clarification. I think I heard it in your video, but I wanted to be sure. So it sounds like your approach is to remove unused code out of the binary. So I guess that would solve problems where new features, new code, new things needed in the future would be solved. Is that true? You're using the binary as the place to do the pruning?
We are working on binary because sometimes source code is not available. But when software is updated, when some new features are needed, we need to collect the new using histories and to do the rewriting to regenerate customized software. That's our approach. Yeah.
Okay, thank you.
Hi, this is Erkan Uzun. Today I'll introduce our novel tool for privacy-preserving facial surveillance. Facial recognition is becoming one of the most powerful surveillance tools ever made. Even though many people merely interact with this technology as a way to unlock their phones or sort their photos, it's being used for a greater impact on people's lives. Governments and companies already use facial recognition for identity check and public safety. But for the most part, people focus on the darker aspect of the technology as it raises many concerns about privacy. Let's take a closer look on the current technology to understand its privacy risk. Computers detect your face from the footage of a security camera. Then, a neural network generates face prints from these detected faces. To identify a person, database is scanned through to find the person with a close face print. Today, the state-of-the-art deep learning tools can accurately identify thousands of people by creating their face prints. If we are talking about detecting and catching criminals, this is a great tool. But the same technology can also be used on law-abiding citizens. In the US, there are an estimated 80 million surveillance cameras, and the numbers are increasing every year. So, if facial recognition companies had access to these footages, they can track the movements of any person 24/7. For example, right now, some autocratic regimes are already using the technology for protester identification. And in response to these privacy concerns, recently major companies such as Amazon, IBM, and Microsoft put a moratorium on selling their software to law enforcement. However, considering its growing market size and deployment across the world, it seems unlikely to completely ban the technology. In our customer discovery, three major challenges have been highlighted for the future of the technology. Obviously, the first one is the privacy protection of the regular citizens. But this should be done without suffering from the performance of existing technologies. And more importantly, any new technology should be compatible with existing facial recognition infrastructure. We address these challenges with a novel tool called POCUS for real-time privacy-preserving facial surveillance. Thanks to its underlying cryptographic primitives such as lattice-based homomorphic encryption, Shamir secret sharing, and garbage circuits, our patent-pending technology guarantees the privacy of the regular citizens, even against the future attacks by quantum computers. Our tool doesn't sacrifice from the performance to achieve this level of security. We can search a person over millions of people in a couple of seconds. This is several orders of magnitude faster than existing tools for similar tasks. POCUS could be installed as a software plugin on top of the existing facial recognition systems, and it doesn't require to replace any of those millions of installed surveillance cameras. It also allows multiple clients to search multiple faces concurrently over the same database, meaning that it can perform real-time surveillance. Our tool is also compatible with different biometric traits such as fingerprint, voice, or iris. Thanks to its unique pipeline, our technology only focuses on to identify people without detecting or revealing their race, gender, or ethnic group. Now let's see how we achieve all of these compared to existing non-private technologies. During our customer discovery process, we found out instead of raw facial photos, companies store the face prints, sometimes impartial, as a protection method. However, this doesn't bring any privacy because face prints are still revealing the biometric data itself since they are reversible. In our technology, server makes all the computations only through the encrypted data, so it cannot detect whose data it's working on. To make such computations, we first convert face prints into biometric hashes for cryptographic computations, then homomorphically encrypt them and send to the server. Then the server homomorphically evaluates the match function and sends the encrypted results to the client. That's why the server cannot decrypt any of the query inputs or the results of these computations, which gives us complete privacy protection. In this way, we prevent companies to store the biometric data of regular citizens while still identifying persons of interest. Let's see how our prototype implementation works. Server still keeps its database in the same way with the existing technologies. In the client's perspective, nothing is changed as it still receives the IDs of the matching people. Thanks for watching.
You know, so I understand the concept of, you know, doing that all under encryption. Most of the use cases, the query happens, you know, later once it's identified that something needs to be looked at. So I guess the question is, once that match is made, you know, if the police a week later are investigating something and need to go back to that data, you know, what if that match is able to be made just based on what you have kept under encryption in the database? You know, what information are they able to get back? That's, you know, I think you've answered it. I think I just have to process it, but I'm trying to understand how the sort of asynchronous queries with that strategy work.
So when we mean under encryption computation, it shouldn't be in our model, in our system. It shouldn't be an offline system. So we are not working on capturing CCTV footages and analyzing them under encryption. We are not talking about this kind of model. So
got it.
You can think regular the existing technology, but we just provide a privacy layer which can work in real time. So every computations are done under encryption. If there's a match, by the nature of our design, parties learn the matching result. But if there's no match, everything is kept encrypted.
Is this something that's installed on all the, you know, on the server level of all that's connected to these cameras that works at that level then? And
so we shouldn't install or change the install of the cameras, but we should install a client software and the server software, which makes the query and which makes the facial recognition. So it only has the two ends. So let's assume if a company collects or if a store collects from multiple cameras, we should install only one software in the client side.
Okay, thank you.
This is a GE gas turbine. Every day, an equipment like this can generate on an average 40 million data points from over 1,000 IoT-enabled sensors. Now imagine you have a fleet of IoT-enabled industrial assets like turbines scattered across the world. The biggest question you'd be asking is, how do I store and analyze all the real-time IoT data to optimize the performance of my assets and reduce downtime? A straightforward answer would be to leverage the cloud to do your analytics. But can you even imagine the downsides to using the cloud on such big data? First, asset owners would be required to migrate sensitive data to the cloud, so data privacy becomes an issue. Secondly, although storing data is inexpensive, the cost of running algorithms to process that data and share insights can escalate very quickly. Edge computing attempts to solve some of these problems by pushing analytics close to the source of data itself. However, that's not enough. In order to obtain fleet-wide insights, data must still be migrated to the cloud. In fact, 80% of the industry experts we've interviewed said that cloud costs and data privacy are their two top pain points. Most complained about the limitations of the edge with respect to its reliance on the cloud in order to obtain fleet-wide insights. These issues are going to become even more important in view of the rapid growth of industrial IoT and the edge. By 2022, more than 50% of enterprise-generated data will be created and processed outside the cloud. By 2021, 80% of industry CIOs will integrate operational technology with IT. Lastly, large industrial entities are increasingly adopting edge-based strategies for advancing their digital transformation efforts. But what if there was a way for edge sites to collaborate with each other without moving any data? This was our primary motivation for creating Blockalytics. Blockalytics solves existing pain points in industrial analytics by leveraging a decentralized platform that delivers the same cloud analytics but without the cloud costs. The Blockalytics platform spans geographically dispersed assets and unlocks the hidden potential of data tucked away in information silos. It allows entities to collaborate and build analytical models across their fleet, all without transferring any data. Blockalytics eliminates all cloud interactions, and using our tailor-made SDK, data scientists can write and port their own analytics applications. It's like an operating system, but for analytics. Using our platform, practitioners can perform data analytics and run machine learning algorithms at scale. It enables sharing of fleet-wide insights while maintaining full ownership of data. Blockalytics wouldn't have been possible without proprietary technology developed at Georgia Tech's Predictive Analytics and Intelligence Systems Laboratory. Our team consists of seasoned researchers with a shared passion for reimagining industrial analytics. We are passionate about building a scalable, robust, decentralized mechanism that is backed by a strong computational foundation. We are looking for investors who would wish to invest in our passion of building a meaningful and practical decentralized platform for industrial analytics. We look forward to interacting with all of you.
Nice topic, and obviously edge compute is a tremendous trend. So in terms of the block analytics and things, and not moving data and moving the analytics around and things, how did you architecturally anticipate doing that? Or is that going to be part of container movement and management or coordination of those resources? I was curious as to how that architecture roughly would work across all those edge compute resources without moving the data.
Right. So basically, so what we showed in the video, that was actually like our product. So that is already live, and we are actually hunting for POCs right now, and we're talking. It's ready for deployment basically. So the way the analytics is being moved around is through container images. So what you saw in the video, that's basically like an analytics app. So you can write multiple analytics apps, because usually you want to monitor different things. In industrial analytics, you probably want reliability, you want process optimization, you want anomaly detection. So each of those things can be apps, and so you can deploy them through the orchestration tool, container orchestration tool. We have, that is part of our platform. We've integrated that, and the edge devices as such. We are not kind of when we refer to edge, we are referring to a broad spectrum. I mean, edge actually refers to a broad spectrum of devices. You could have like a very small microcontroller, or you could have a really big server that is sitting on the side. So basically, our definition of edge is like a small dual core CPU with 4 gigs of RAM. That is kind of like the minimum compute requirements that are needed for orchestrating that. In fact, that is the same as what you saw in the video as well.
Great, thank you.
I guess some of mine are, when you talk about the issues with scaling and traditional cloud, you've got storage and the secure data challenge, and then you've got the compute challenge. And for the data side, and both of them can be expensive as they scale, and both of them, decentralized network makes sense for that. I guess, the broad question is, which of those is the primary motivator here? And then, and what I'm building towards is, if it's storage, then this is almost like BitTorrent in a way, as far as being a decentralized network of moving the data around. And if it's compute, how much of this is truly blockchain? And if so, is it like a proof of stake or a proof of versus proof of work algorithm? And I'm not sure that's necessary here, so that'd be a good thing, maybe, that it's not really blockchain. And I'm thinking about things like, I guess all the nodes would have to agree on things like retention and history and how much data they would all want to keep, because otherwise this just grows out of control with no end in sight, right? So sorry, I threw a number of things out there, but I'm looking forward to your responses on any of them.
Yeah, so I think like broadly, like you were asking for 3 questions, right? Like the first question was about the first question you had was about like the scalability challenge. So basically the scalability challenge, for industrial analytics specifically, right, with respect to the cloud and industrial analytics, the challenge comes from the compute. The fundamental challenge is compute. So there are companies that we've spoken to during our customer discovery process, including one that is in Atlanta downtown. It's a huge paper manufacturing company, and they spent $25 million on just cloud compute costs. $25 million, because these equipment are like, they're really bulky and they stream like gigabytes of data per second. Storing data on the cloud is not an issue. Storage is not that expensive. You can keep dumping all your data. But when the time comes to crunch that data to give predictive analytics to kind of tell you when the equipment is going to fail, prognostics, diagnostics, that's a whole different ballgame. So, data science teams at these companies, even small startups, they spend close to $20,000, $15,000 per month in training, retraining, and they're keeping on training and retraining. So that kind of the cost of the compute is a fundamental, fundamental challenge. Now, the other thing that you spoke about was the blockchain. Although I didn't mention the blockchain anywhere in the video, but I think you were kind of, you kind of caught on to that. So it is the blockchain that is powering this. But here's the most interesting thing. Traditionally, the blockchain has been used for like some, because of its immutability characteristics. That means once you put data, it's not possible to change it and tamper proof and all that. But the question really is I truly believe, in our group, we truly believe that the fundamental innovation of the blockchain was decentralization itself. You had decentralization first. And with the advent of smart contracts, it's giving you this tool to, orchestrate compute. Never before has it been possible to orchestrate compute in a decentralized fashion like how you have on the blockchain. And instead of using that as the primary thing, people are kind of going and trying to do all other types of stuff like tamper proofing, immutability, and other stuff. So that is what was, that was kind of like because my research has been on decentralized computing. And the one thing that I keep always, that I'm not able to figure out is there is no platform available to do decentralized computing, even though everybody knows that decentralized computing has so many benefits. So this is kind of like, we are using blockchain in a very kind of innovative way to actually orchestrate that decentralized aggregation fabric across all these sites. So that's the other thing. The third thing you asked was about like, whether it is proof of stake, proof of this thing. So because of the fact that this is all being done on a private blockchain, right? It is not a public blockchain. All of this is across industrial assets that are within a company. It might be in a consortium of industries, and you have a private blockchain that allows us to kind of get away with removing so much of algorithmic complexities that computational complexities that come with proof of work and proof of stake and all those types of things. So, and the other thing is, because it's blockchain based, you can pick and choose whichever consensus algorithm you want. Like, you can have a Byzantine fault tolerant system. You could have like, like a simple proof of authority and things like that.
All right, wow. Great, really fantastic presentations. And of course, really great questions from my judges. I know that everyone is sitting and thinking, just like I am, that Georgia Tech continues to have amazing technology being incubated in our research labs and ultimately getting ready to be pushed out to market. So, I mentioned earlier about this People's Choice Award, where you've heard the presentations, you've heard the questions from the judges and the responses, the really thoughtful responses from our students. So now it's time for everyone to make a decision. And we're going to open up voting. And if you look on the screen, you'll see a link. And we're going to leave the polls open. Don't worry, we're going to give you about 2 minutes or so to look at your notes, to think about who you want to vote for now. But we're going to leave the polls open until the awards begin. So go for it. Okay, so I hope you've made up your mind. But again, if you have not, remember we are going to leave the polls open, so you can still think about it. But while you're making up your mind, we're going to go ahead and jump to the research track and introduce these students. But I hope you made note of the link. If not, we can put it back up later. The research track is offered to students who may be at a little earlier stage in terms of TRL. And I'm going to let each of the students introduce themselves and tell us a little bit about their research. And let's start with Young Wook. I think you might be muted, Young Wook. We can't hear you. No, we not yet. We'll give you another 15 seconds or so, and not I can introduce you. I have some background information. So why don't let me do that, and then I'll ask the other students to do. So Young Wook Do is in the School of Interactive Computing. He's a PhD student, and the research is called Spidey Sense. My 7-year-old would love this. Designing risk-mounted effective haptics for communicating cybersecurity warnings. And there are other members of the team, Ling Wang, Hong Jung Park, and advised by Professor Gregory Abald and Savik Das. Okay, Dan, are you here to introduce yourself?
Yes. Hi, can you hear me?
Yep.
Hi, my name is Dan Lee. I'm a 5th-year PhD from the School of Industrial and Systems Engineering. My research is on detection and differentiation of cyber attacks and equipment faults in SCADA systems, or the industrial control systems in general. So my team members include my advisors, Professor Nagy Gabriel and Professor Cameron Pelabar, and I would like to also say special thanks to my committee members, Professor Sakis Meliopoulos and Professor Jan Shi. And also, I would like to thank the program for this great opportunity, and I really appreciate all the questions from the judges and the amazing works from the other competitors. Thank you.
Okay, and Moses.
Hi, can you hear me?
Yep.
Okay, waiting to appear on the screen. So my name is Moses Ike. I am in the School of Computer Science, and my research is about forecasting malware capabilities from cyber attack memory images. This involves the ability to leverage the memory images captured from an IT enterprise and be able to use it to forecast or predict what the attacker would do in the future. So we're able to use these memory images and look into it and analyze what future payloads the malware has staged for execution but has not yet executed. So this would actually help enterprises to defend their machines from cyber malware attacks. And my teams are my advisor Wenki Lee and my co-PI Brendan South-Formaggio. And I'm looking forward to everything that is going. Thanks.
Yeah. All right. No, thank you. Really fascinating work. Really exciting stuff that all you guys are doing. Thanks to each of you for participating and sharing your research with the judges last week. We're going to hear from the judges after we review the People's Choice Award. Blake, I think you have the honor of announcing the winner of the Research Award and sharing some insights.
Yep. Can you hear me?
Yep.
Yeah, Blake, we can hear you. Go ahead.
Okay, we're good. All right. So we're going to go ahead with that ahead of the People's Choice. Well, I guess first I'd like to say congratulations to all three participants on behalf of the judges. We were super impressed with these innovative approaches to real-world problems and the presentations. You certainly made our job difficult. Young Wook, we liked there's a clever approach to addressing security, by communicating severe threats viscerally so that users will pay more attention and sort out from the noise of all the volume of alerts. We're also, I think, impressed with the amount of testing that you had done of your wrist-mounted haptic method and what you've learned from that so far. And we all felt like we were looking forward to seeing the results as you're able to pair that with the ability to prioritize threats that would trigger that method versus traditional security methods. And then lastly, I think we all recognize that approach has applicability beyond just cybersecurity. So there's other market opportunities with that. So great job. Dan, we thought your research and presentation really did an outstanding job of highlighting, that the problem, certainly the risk of malicious attacks to critical infrastructure with, industrial control system environments, and, highlighted the need of distinguishing data integrity attacks from just natural equipment faults. Your market discovery from RSA was well articulated, and your monitoring simulations to date are certainly an encouraging start to helping you validate and develop that framework. So we were super impressed. Thank you. Moses, we certainly recognize the innovative approach to using memory images to recognize those deviations and predict malware execution from unknown code, and how that would supplement conventional or existing security methods. I think in particular we like that you highlighted that this can be incorporated relatively easily and have significant impact alongside these existing solutions that are already capturing the memory images, but only using them for forensic purposes, not predictive security today. And you're on the promising path and on the right track in all the conversations you're having with companies. So and the other existing malware solution providers. So keep that up. So again, really tough decision. We actually debated this category quite a bit. I think if it was up to the judges, everybody would have won. But with that, I'm excited to share that the winner is Moses Ike and forecasting malware capabilities from cyber attack memory images. Congratulations.
Thank you very much, Norman. I guess my head is blown. Actually, I've been working on this research since the beginning of my PhD, and I've been helped by my co-PI, Brendan Sottoformaggio, and our paper actually got accepted. And I'm very happy, and I welcome every opportunity to talk about this research. And anybody that have questions, I'm just hoping to discuss more and to see this research actually transition from core research to actual something that can benefit the community of cyber users and enterprise. Thank you.
All right.
Okay, now Raheem, I guess I'll hand it back over to you.
Yeah, sounds good. Hey, Moses, congratulations again. Outstanding work, and congratulations on the award as well as getting the paper accepted. That's a big deal. All right, so yeah, we're going to give you guys one more chance to vote, and then we're going to officially close the People's Choice Awards and move to the judges to provide thoughts about contestants and winners. So you got about a minute or so, and we're gonna move forward. All right. You are awaiting the answer or the winner. So we just heard from Blake that Ike was a winner of the research track, and we're going to go to Jerry Perillo, who's going to announce the winner of the People's Choice Award. So Jerry, I'm going to pass it to you, and let you do the honor.
Thanks, Raheem. Yeah, I've got my 7-year-old here as well. I'm sure you'll relate to that. Hopefully, she'll be competing for one of these days. Yeah, I really had a great time judging these projects. It's always great to be close to them, and fantastic job. And I'm excited to announce the winner of the People's Choice Award, and it is Erkam Uzun in privacy prevailing surveillance. And congratulations, Erkam. We had a really good time reviewing this one, and we can definitely get the idea here. And this is an idea whose time is hopefully come, and I can see a lot of future applications for that. So great job, Erkam. Congratulations. And for our next segment, I'm going to hand it over to John, who's going to go into even more detail there.
Thanks, Jerry. Can everybody hear me okay?
Yeah, you're good to go, John.
Great. So on behalf of all the judges, I want to provide a brief overview on the commercialization track. And as I know all the judges would say, we saw some great work from all 4 of our commercialization entries. And the deliberation of the judges was quite extensive. No easy calls here, and some great work by everybody. But I'd like to share just some of the comments of the judges for all 4 of the commercialization entries. I think the first one we all heard about was Ranjita and TARDIS. The judges really liked Ranjita's novel approach for using existing backups and that infrastructure to detect attack vectors. We applauded your extensive market and customer discovery that helped you uncover market differentiators and the relevant market opportunities across the supply chain. So we thought that was a great piece of work there. We were impressed, with the seamless and agnostic integration strategy that will allow you to more easily scale your product in the commercial world. And we agreed with your next steps towards deployment, including finding, pilot customers, focusing on your UI, and building an automated back end. And we also agree with keeping your business model as simple as possible. So it was an excellent entry, of course. And then the second commercialization entry that we looked at was Chin-Chon with Razer. And, the judges really liked Chin-Chon's novel, Razer technology, and thought it was very compelling. The ability to remove code without needing the source code and retaining the functionality in runtime clearly gives this idea an advantage over other competitive technologies. Your approach to what seemed to be an untapped market could have a dramatic and disruptive impact on the industry. So we thought that it was a very interesting idea. If companies were able to eliminate vulnerabilities associated with, unwanted code and unwanted features that weren't necessarily needed in the build, that would be very interesting. We like that you're doing, customer discovery, and recommend you to continue to explore customer workflows as you develop your go-to-market strategy and determine more about the exploit coverage that this type of capability, would provide. So another excellent entry in the commercialization track. The third entry that I wanted to share some of the judges' comments was from IRCOM. This was another very, very interesting ones with privacy preserving surveillance. We like IRCOM's approach in taking a focus on privacy preserving surveillance that could be integrated into software and launched via probably most, if not all, of the existing cameras across the country and perhaps even the world. This is an important consideration when scaling your technology, having easy integration into the deployed world. Our assessment is that you've applied a highly sophisticated technology, into an easy to use platform that applies an encryption and privacy layer when capturing these biometrics. Your customer discovery is an important step in validating, your technology as you formalize your go-to-market strategy and what I would, judges would call your product market fit, which we think is also very, very important. And that brings me to our fourth entry, Paratosh with Blockalytics. The judges were impressed with your platform, which leverages, blockchain technology to deliver and execute decentralized predictive analytics, including machine learning. I think the optimization, for various industrial IoT applications while preserving security and data privacy through blockchain is very an interesting and very good idea. We specifically, talked about how you tackled the problems related to cloud-based analytics and the trend in the industry into edge compute, which are, two very important industry trends that we think are incorporated, into this approach. And, this whole idea of blockchain as a tool and the trend of edge compute is huge in the industry. So just like the other two contests, we had a tremendous amount of dialogue and input, and it deliberated for a while on very, very good 4 entries here, and it was a very, very close call with great work by all the submissions. But there can only be one winner, and the judges struggled with this. But we thought all of the submissions were brilliant. They were thoughtful and had a need to continue that work in research as well as commercialization. But we need to narrow it down to one. So I'm pleased to announce on behalf of all the judges of the commercialization track that we've selected Paratosh and the decentralized cloudless platform or the industrial analytics. Our rationale for selecting this was the combining of several important technologies and even industry trends, including blockchain and the distributed ledger of blockchain against a huge industry trend with edge compute and enabling things like machine learning. And this was achieved with a tremendous amount of focus on security as well as privacy, with the data that could make edge compute more consumable by all the use cases in the globe. So congrats to all of you on your submissions and entries, but a big congrats to a winner selected by the judges, Paratosh.
Thank you. It's obviously like I'd like to take a moment to kind of thank my advisor who's here, Professor Gabriel. We are both, and Dan Lee, we three, it was our research that kind of, took place, it's been in the works for the past 2 years. And Professor Gabriel and I have kind of, really spent a lot of time deliberating on, this idea and what are the pain points and how our research can address these pain points. And the other thing I would like to mention is that I'd like to take this moment to thank the Sam Nunn Security Fellowship Program. So it was actually because of that Sam Nunn Security Fellowship Program where I was looking at cybersecurity for the power grid, that I understood that this type of problem exists. And what can I do as a researcher to solve this problem? So that's when this idea popped into my head of trying to use the blockchain to kind of give kind of a fleet-wide decentralized analytics platform. So I'd like to thank everyone for their support, and I'm thrilled and honored to kind of accept this award. Thank you so much.
That's great, and congratulations to you. And Rahim, I guess this moves the program back to you.
Yeah, absolutely. Thanks, John, and congrats again, Paratosh. This is a big deal. I hope that I know your advisor Will Nagy. I hope he gives you the evening off to celebrate. I'm sure he will. But congratulations again. We are going to move to the next phase of the event, and really the last piece, which is Rahul Saxena, he's from CreateX, and has been a tremendous supporter of the IISP, and he's going to award the CreateX Launch Prize. So Rahul, if you can walk us through your award and the winner.
Great, be happy to. So I'm Rahul Saxena. I'm the Associate Director of CreateX Startup Launch. Every year we're honored to award direct entry into the CreateX Summer Startup Launch Program, which has $4,000 of funding plus services, including space and legal fees, along with some great coaching and mentoring. This program has always produced great talent, and been excited to work with them. I'm excited to announce that the winner of the CreateX Invitation Award is Erkam Uzun for the privacy preserving surveillance. Super excited about what you're doing and see how we can help you just further bring it to the market. I think it's a much needed technology and solution out there. So congratulations. We'll be happy to have you on board and help you throughout the summer in the May.
Thanks again for the award. I'm very glad my research is appreciated by the industry, and I'm really looking forward to go beyond and for commercialization. Thank you.
Great. We're always impressed with the technology that comes out of the IISP program. So it's being the top one, probably the top program in the country. There's a lot of talent to come out, and we encourage everyone to apply into Startup Launch and see how we can help. But we'll be excited to see where your technology ends up. With that, Rahim, I'm going to go ahead and turn it back to you.
Yeah, perfect, Rahul. Thank you so much. And Urkam, you also get the night off. So congratulations. Take some time and celebrate. Thanks again, Rahul, and really for everyone for participating in this event. And again, congratulations to all of our outstanding students. There's one more award that I just got word about that I want to just brief you on. And it was confirmed that all of the students that are participating in the commercialization track are actually invited to attend the NSF regional program. And that program will prepare you for the NSF, the national program, and eligibility for 50K to do custom discovery. So congratulations to each of you on that. This is a great program. I actually went through that program with one of my PhD students about 4 or 5 years ago. So congratulations. And I want to turn it back over to my colleague Winky to just give closing thoughts.
Yeah, great. Thank you, Rahim. I think you did a fantastic job running and hosting this event. Really, I wish I could be as funny and as well-spoken as you are. I mean, I hope everybody who participated learned a lot from this event, not just from the students, also from our panel of judges. I mean, think about how how insightful they are in their comments and very thoughtful. I mean, they really put in a lot of work. I really feel like I learned a lot just by interacting with them in the past couple of years, and certainly their contribution and help to our Demo Day program is very invaluable. So again, I want all the students and also researchers to keep in mind that at Georgia Tech, I think we pride ourselves of doing research that is impactful, right? So we shouldn't just be worrying about only the next paper. We should really strive for getting our research results to the real world and change the world for the better. And I think that was the main motivation that we created this Demo Day program. And we're learning a lot through this process. And with the new School of Cybersecurity Privacy, again, we're going to put a lot of emphasis on helping students think through just the pure academic work. We want students to think about how do they make their research relevant to the real world. So you would probably hear soon from us some of the new programs, new facilities we're going to put in the new school, and certainly our friends and partners like the judges that you see today will continue to help us. So again, I really encourage all the students to think about what they can learn from Demo Day, and certainly reach out to the students who have already participated in this program. And I really want to see more students in the Demo Day program in the coming year. Okay, thank you all.
Recording has stopped.